have heard of Chef Metal in the first place? How many of you know what it does? Like how? Let me go through the beginning then. So the purpose of Chef Metal is the biggest purpose of it is make it so we can manage entire clusters the way that we're currently managing machines with Chef. I'm John Keiser. I'm the lead of Team Ronin and resident mad scientist at Chef. And I want to talk a little about Chef Metal and why I made it. And the reason I made it was that when I'm developing software at Chef, I need to deploy it to places. I need to deploy it so I can test it. I need to deploy it over and over again. And I found I wasn't testing it as much as I might otherwise because deploying it was really scary. I found the knife commands were really hard to understand. The playbooks were out of date, which gets into like the whole reason we made Chef in the first place is Ops used to be, well, it's still done with playbooks. Just a lot of our playbooks are in code. It used to be that everything was a huge book. It was literally, they were literally books with instructions for what to do, what to type in every circumstance that could possibly happen. They enabled item potency, like if it's down, here's how you bring it up. It's just that there were a lot of very long steps to do it. And Chef changed all that by making it so we could just describe those playbooks in code and let the computer do that for us and let us think about how we want them configured. You know the basic reasons we wanted to do Chef, but they're important because we're going to want to do them to replace this playbook, which is the playbook that I used when I wanted to redeploy the pushy servers that I was developing. This is one piece of our playbook. In the knife EC2 commands, the AMIs and all the many different options and where I had to put my keys. I was a novice at this, but still it was not clear to me what anything that I was typing was doing, and the experience just kind of sucked, so I just kind of didn't do it. I probably actually brought up the server once, and I would just let the thing up and try to put my software on it for the next 9 months, and that's not cool because I can't like test whether it installs in the first place. For example, you kind of want your software to install. So clusters, like the dream that we have for these clusters is the cloud. It's this magical place where we can bring up 100 servers and that's our whole cluster. That's everything in it, and it's just beautiful and it's fast and it's parallel and it's free and other people are dealing with the machines, which is important. Unfortunately, the reality is a little bit more like this. And this is, by the way, this is actually someone who's written a children's book, fully illustrated, of the Call of Cthulhu. And this is a slide from that with full like Dr. Seuss rhyme and everything. So yeah, all these problems, like we have these clusters. How do I version them? How do I test them? How do I make them again? How do I manage the machines in them at capacity? Knife EC2 has 10 million parameters. Which protocol am I going to talk to? Which cloud container events? I just want to converge my stuff and start using it. This makes Buddha cry. So this is Chef Metal. This is the idea of putting this into Chef. This is a recipe that can install a database and a web server and run the MySQL and Apache recipes on them. This is the basic, the most basic and most important part of Chef Metal is the machine resource. The idea is that we're going to be describing the machines in our infrastructure in code, in Chef recipes. things that can be written down once, versioned, deployed to multiple places. Make one in Vagrant and test it, and then send it to AWS when you're done. The way that this is an example run, but I can actually run one if you want. Live demo crash. Let's see. So in the Chef Metal repository up on GitHub, it's opcode/Chef Metal. There's docs/examples, which has at least a few examples that you can use. And whenever I'm testing the thing, I actually just cd into that directory and run stuff. The first thing you have to do when using Chef Metal is set which driver you want, and we'll get into more of that later. There are a bunch of drivers. I'm going to use the AWS one because it's nice and fast, and it's not going to bog down my machine, which is not hooked up to power right now. And so I'm going to run. See, is simple still simple? It is. In fact, let's make it simpler. I also modify these recipes in order to test different things. So at different times of day, simple is not actually a very simple recipe. And we'll also find out whether I already have a Mario machine or not. So when we run it, what it's going to go do is that one machine resource that I put in the chef recipe, it's going to go load the AWS driver, and then it's going to create a machine on AWS. Very first thing it does, very first green line you see there. It's automatically created a key on my machine so that it can SSH in and do its stuff. It's going to create a node on the chef server so the chef server knows where it is. And it's going to update the tags so that it's nice and pretty on the AWS console and I can look at it. And there are a ton of Marios in the chef account at this point because this example recipe is what everyone's using to play with it. Yeah, so then it waits for it to be up, then it connects to it through SSH, installs chat, and runs the recipe. This can be done in parallel as well, and it can be done with multiple different recipes. So it's also idempotent, so I can hit Control-C and hopefully not in front of an audience have it fail. But the next time that it runs, it's idempotent, so it will pick up where it left off. It will go and notice that it hasn't finished running chef. So let's make a couple of Luigi machines. Luigi 1. And we'll just, you don't need to put anything on him. He's a second, he gets second billing anyway. And we'll rerun it. So an interesting thing that you're going to see here is it's idempotent. So that the second time that you run the recipe, it's going to see that machine Mario, and it's going to notice that we already have that machine. It's not going to recreate it, so every time you run the recipe, you're not going to get another a duplicate Mario. And it's going to notice that it does not have Luigi 1 and Luigi 2, and it's going to go up and actually provision those. And you can see it in the background actually now running Chef Client on Mario. It picked up where it was left off and actually reinstalled safe just now.
So first it did it checked for machines first, that's the base thing. Irrespective of it saw that Mario was there, it didn't continue the chef there until after. The first thing it does is make sure all machines are present, then it moves on to provisioning the chef.
I think what was happening there actually, like it does all of them in parallel, and so it's going to check that all three machines are there. But what was happening was in the background, it was going and saying, hey, do I have the right chef client version? It's not going to print anything until it notices that there's something that actually needs to be fixed. So that if there's nothing that needs to be fixed, you don't see any green text, and you know that nothing changed. So that's another feature of it. By default, everything happens in parallel, and you can control how things go in parallel. We can get crazy and make 50 of them if you want. How many do you want to make? 50? Do I hear 60?
100.
100? I don't know. We'll see if our account actually can handle that. Why not? What could possibly go wrong? So the driver's all written in parallel, and what it does is it goes and talks to the driver and says, I've got 100 machines I want, or in this case, I have 98 machines that I want you to create. And it's going to make one request to AWS to create all of them, and hopefully we'll see what's green.
I think one important point to clarify is that this Chef client run is happening on your laptop.
Yes, and it's going to AWS over Wi-Fi, and I'm uploading the Chef binary over Wi-Fi and all of that good stuff. So thanks for the Wi-Fi.
So you're saying that the net effect the server is your local machine? It's not a centralized server somewhere on the
It's not a server.
So there's no server out there acting as a shared server?
In this case, that's true. In this case, I'm running Chef in local mode. And so what's happening is it's spinning up Chef 0 locally. And when I create these machines, because I didn't tell them to go onto any other Chef server, it's actually registering the nodes back on my machine through an SSH tunnel for the Chef 0 instances running on my workstation. So those AWS machines are actually sending all of their data back, and they're asking for the cookbooks from my repository on my machine.
So there is a Chef server that is running on this machine, and it is doing
Yes.
SSH process.
And so that's one of the design principles of it is actually that you're not forced to like when you're running resources on a single machine, you don't have an issue where you like there's only 1/temp/text, and you're not gonna there's not multiple places it can go, and that's not the case here. Like I could create a Mario in AWS against my production Chef server. I could create one on Vagrant against my local test instance. I could create one on the staging server against my set of OpenStack machines.
But you're actually creating 100 of them here based on the recipes that are on the local machines. So they don't represent the actual map.
That's correct. So what you can do is you can tell them, even though you're running it from Chef 0, you can say with Chef server, and so it'll run Chef 0 locally, but it will point the machines at a different Chef server. You can say, I want 50 of those Luigis to be in AWS, maybe another 25 in AWS East, and maybe another 25 over on Google Cloud Compute on the same recipe. It'll go red. At the end, it's going to report which one failed. It shows what the failures are. As long as you're piping the log to a text file, yeah. This is the log the way it is. This stuff is being logged using like Chef log. So like if this is, I haven't really been looking. It could be that there's a log file it's also sending it to, like keying it. But basically the output of all those Chef runs is actually being sent back. A feature that some people have asked for that is high on the list, although I don't know if it's going to make it to 1.0, is actually making it so that each server's output gets sent back to a file for that server. My machine is bored with creating 100 machines, apparently. So while it's doing that, since it seems to be fairly green, we can continue on a little bit. And this is looking a little bit elementary at this point. You can see a little bit there of the Chef run is actually going to print its output, and when you're running a bunch of recipes, it's actually going to show that the resources it converges, and sometimes it's going to converge, actually change something, sometimes it's not. So that's the simple Vagrant way. I really need to make this slide so you can actually see it, but that says VirtualBox. What's happening is the metal recipe is running on, that's your workstation. And it started up a little Chef Zero. It creates two Vagrant machines when you run that piece of Vagrant driver, and it points them back at your local Chef Zero instance, which is serving up the files in your directory. So if you put a cookbook in your directory, if you put a role JSON in your directory, if you put an environment in your directory, then these machines will see it. Not only that, these machines are going to put their node data back here. And if one of them has a recipe that does a search, they're going to be able to find each other. And that's actually one of the more important things about it. Whether it's Chef Zero or a Chef server, they're all pointing at the same Chef server. And once they've registered their IPs, they can do that. So the two concepts in it are the machine resource and the drivers. We talked a little bit about each. There's really, like, at this stage, it is the machine resource. The idea in general is that we want to provision all the things in our cluster. So we have resources for modifying all the data on the Chef server idempotently. We have resources for creating instances idempotently, and high on the list is getting some things to create things like AWS load balancers, stuff that's global to your entire cluster. You want to be able to write all it down in one file, create that cluster, and then if you need to create it again in a different place, you should be able to do that. The drivers that we have support, we have a fog driver that supports a lot of cloud instances, and VM driver using the Vagrant. There's a Vagrant driver. Containers, we got LXC and Docker. Also in kind of the mix between the cloud VMs and Metal, there's a vSphere driver that someone has written. I've written like 3 or 4 of the drivers, and there are 2 or 3 other drivers that other people have written. They're fairly easy to write. At this point, there's something like 7 of them out there. And we have bare metal in the form of SSH. We don't have like Razor and Handlin yet, but I will release that before 1.0 so people stop yelling at me about calling it Chef Metal. So the nice thing about it is it's Chef. It's recipes. There are other solutions out there. We've got solutions that let us modify a YAML file, solutions that let us write some JSON, but these are static solutions that try to guess everything that we're going to want to do with our infrastructure and encode that in a static configuration. The powerful thing about Chef has always been you can do whatever you want. You can load whatever library you want. You can put code when you need to. When you don't need to, you just write resources, and then you make it more complicated when you need to.
So Metal itself is a resource.
Just a resource in Chef.
So I just fire up a new recipe, and my clusters are basically using these resources, and then production gets a little heavy, so I say, oh, well, let's just up the region to 50 units instead of 25, press the button, and it pushes it, and we're done.
Yep. That's, and that's actually what we just did there.
Right. That's what it looked like. I was just verifying.
Yeah. And actually, that's an interesting thing. You can push that number up yourself if you want. There are other ways to do it, though. It's code. So we had a little loop there that. All right, we're gonna just stop. I don't know why it's taking a long time, and I don't care right now. So we put in a constant there that said 1 up to 100. You can imagine, though, something that like that doesn't have to be a constant. This is code. We could go and say we could go monitoring server dot how hot are the CPUs on the Luigis, and if that's greater than 100, then we'll up the number so that the Luigis aren't so hot anymore. And so we can set a number that like calculate how many we want based on that. put it in there, and once that happens, this recipe runs. So you can have this recipe run every 5 minutes, every 10 minutes, every 15 minutes. When it notices that the Luigi CPUs are starting to destroy the racks, then we can go and add 50 servers pretty much instantly in code. We don't have to do it manually. And you can imagine, pretty much you can do anything, and you can drive that based on any values you have in your infrastructure, wherever you're storing your data, wherever you're storing your monitoring. So this was important to me because the command lines, the knife EC2 command lines that scared me were really the thing that made me want to do something different. And so I made sure we have a command line that doesn't make me type a bunch of parameters. So Metal actually stores the information about where the instances are, and enough information for you to find the keys on your hard drive and easily SSH. So you can do a login or an execute. You can do a delete or a converge. The data on how you're setting up your machines can actually be stored in config. So you can even make a Metal create that will actually just create servers from the command line. Again, without having to know anything other than node names and the chef server that you're pointing at. So that was important to me. I just want to be able to go and I know the name of the node. I know the thing is a web server. I don't want to have to go look up its host name and IP and all this other information before I can go and fix it. Yeah, we already added a new machine. That's part of the reason I wanted to do the demo at first, is because it we skip half of the we could skip half the slides and we could just ask questions at the end. So yeah, this is adding another web, and the web 2 is the only machine that actually got created. The other two are still there. The nice thing about it is that you can take these recipes and you can point a recipe that you had originally pointed with AWS. You can take that whole cluster recipe and point it somewhere else, because it allows you to specify things in terms of logical definitions. You'll notice the recipes that we've been creating so far have nothing in them that are really specific to AWS. There are ways to specify the options for AWS in other recipes or in configuration, so that you can write a recipe that just says, I want one database master, one database secondary, and 30 web servers. You write that down, you say what's supposed to be on them and how they're supposed to work, but you don't say they need to have 8 gigs of RAM. They need to be this particular AMI. You put that, or they need to be in this AWS account in the East region. You put that stuff in configuration outside and run the recipe against that configuration, and it's going to put the stuff in AWS East. Change your configuration to go to AWS West, different AMI, different information, and you just change the configuration, run the same recipe, and now you have 2 copies of the same cluster in 2 different availability zones. So this is just demonstrating that you can also point it to Vagrant and AWS, which is an important scenario for me, because I want to be able to test my server. And when I write all these recipes to set them up, I want to be able to still use them when I deploy them to production. Or at least have them be close enough that when I deploy into production, I'm not just starting from scratch. And I know the thing I tested is pretty much the same as the thing I'm deploying. Continuous integration is another scenario. This is glorious. I think this slide is just worth looking at. This is a hamster mech. So continuous integration is another big scenario. You can imagine having a Metal recipe sitting on your Jenkins node, and that's Metal profit, by the way. you check in your metal recipe into your repository that tells it how to spin up a bunch of machines to run your cookbook, or your set of cookbooks, or your entire infrastructure. It's checked in, it's version controlled. And then on the Jenkins node, the job that you run does a chef client run and spins up machines to actually do the test. So now we've moved the provisioning from your node to a node somewhere else. This is just chef. So the recipe can run that cookbook. When it first starts up, it's going to actually provision the rest of the cluster. What's more interesting is that provisioning node is going to be running that cookbook every 15 minutes. One consequence of that is that if your machines actually go down, then it's going to create new ones, because that's what idempotent does. So it does have self-healing in it. Another consequence of running on the provisioning node is now we're all working on creating processes for when we change all our recipes in our cookbooks. How do we get them all the way to production? How do we test them, go through a series of gates, and finally we put them in production, and we've been through so much QA that we're actually pretty confident they're going to work. But we're not doing that with the scripts that set up, that bootstrap our machines. Now we can put the cluster cookbook through the same process. And when we're finally ready, we put it through test, we put it through the staging environment, and then we upload it to production. That provisioning server just kicks over and every 5 minutes downloads its cookbook. And for example, you added a new kind of server. You decided to add a RabbitQ server, and it's going to provision that, put it in, install the software on the other boxes that actually talk to it. You've upgraded your production cluster without manual intervention. I do recommend that you actually watch and make sure your app still works. I don't know why we're still talking about growing the cluster. Billy Joel, people, come on. So yeah, we talked about this a little bit already. Like upscaling is just adding new nodes. You can drive the variables off of whatever you want. The only reason I put a downscaling thing in here is because if you do go home and make an upscaling recipe, this is something that you should think about. So the way metal is an additive thing, and so like what's going to happen is if you say I only need 10 Luigis, and you do that loop, it's going to create 10 machine resources and say, I got 10 Luigis, that's cool. Well, you got 15, but it doesn't know that you don't have it doesn't know anything about those other 5 because you didn't describe them in the recipe. What you need to be able to do is say, I need to have Luigi's 1 through 10.
Or does that through the Luigi?
Yes, the name is like the name of the node. That is actually the name of the node on the chef server that drives it. I don't know why it's not coming up, so we'll... Oh, maybe I did. Okay, cool. Thank you. So what you actually do is you go and do a search and say, okay, what Luigi's do I have? You can do a search for like tags web server or name Luigi star or whatever you want to do, and then you subtract. You say, okay, I have Luigi 1 through 15, and I only want 1 through 10, so let's go through and do action. I changed the name to destroyed to make it sound eviler. Wanted to like just convey the weight of the actions.
So you're doing discovery there through basically search, which is lookup of the chef server itself.
Yes. The whole thing is parallel, and instead of doing this one, I'm just going to open up a recipe. So parallelism, we've already seen, like by default, you look in this recipe, all I did was describe a bunch of machines, and it ran them all in parallel. That's not always what you want. Sometimes you need one machine to run first, and then a bunch of other machines to run. And you need to be able to control that parallelism. I would do, actually, I'm going to show you the recipe that I show everybody that you should never ever run. That. So you can actually do it in a machine batch, and the machine batch is a unit of parallelism. You say, I want these machines destroyed. It'll actually make one request. It will do it quicker than you can say Control-C. Let's see, we're going to... So this issue of you want to do as much in parallel as you can, but sometimes you got one server's got to go, and then another server's got to go after him, and then everybody else can go, or something like that. Well, the machine batch is a unit of parallelism. So what you can do is you can say, I want to do these machines in parallel here, and I want to put these recipes on them, and do that step in parallel, and then I want to do something else. In this case, what we're doing is we're installing a 4-machine cluster where there's a primary and a secondary, and they're in this complicated DRBD initialization thing, and the primary has to come up and do his setup, and then the secondary has to come up and do his setup, and then the two guys are linked, and now everybody else can talk to them. One way you do that is just do these last 3 things, right? You could just bring up machine primary, bring up machine secondary, and then actually that should have web 1 and web 2 in it, and then do the rest of the shit. So you can do that. One of the issues with that, I mean, it's not terrible, but you're gonna spend a whole bunch of time. You're gonna spend the 5 minutes doing machine 1, then you're gonna do 5 minutes on machine 2, and then web 1 and web 2, they're gonna go at the same time, so it's just gonna take you 5 minutes. But to do all 4 machines in serial would have taken you 20 minutes, and you've just brought it down to 15. It's not all that useful. A nice thing that you can do, though, is in Chef Metal you can actually specify the same machine multiple times and do different actions on it. So one thing we can do, and I'm going to make this a little easier to read than there's a nice syntax there, but we'll do. You can actually say, I want to prime all the machines first. I'm not going to do any of these finicky actions that actually require one guy to be up. I'm going to do that stuff later, but that's only a fraction of the time, right? I gotta spin these machines up. I gotta get an OS on them. I have to apt-get update. Oh my god! And then I have to install a bunch of my company's base security cookbooks. So what you can do is say, let's spin all the machines up, and make sure we have balanced parentheses. Let's spin all the machines up and put the base recipe. So these 4 machines, none of them know who's going to be the primary. They don't know about DRBD. They don't know about Apache. But they all know that they got to do these relatively expensive base recipes that's going to get them all warm. You get them all warm at once. That takes 4 out of your 5 minutes. And now you can go and do the primary initial HA setup. That takes you 30 seconds. You got 30 seconds for that. You haven't reduced it to 5 minutes, but you've got it down to 6 or 7. And that's a pretty big win, especially if you've got a cluster that you're spinning up all the time for testing.
Question about this. Is this only additive? So when the second time the machine comes around, you're adding a recipe and like
yes.
Yep. So I'm wondering about one of the things I'm running into with Chef Metal is I've been unable to use it with Chef Vault because bootstrapping process where I might have to bootstrap a machine for chef vault with the base recipe and then add it to a search so that it can be granted access to a data bank vault, and then you can add recipes that use that data bank.
Yeah, and this is one way to get around that.
So is there a construct in Chef Metal yet to do that granting? To do like there's a night vault update command that can actually do the search and then grant the machines. And if you could run that in the middle of this recipe, that would actually solve that.
Yeah. Well, it's a thing you can do is you can say is do this beginning part. It's something I'd like to have handler type things in there, but right now you can do it by specifying I'm going to set up everybody's base machine when everybody's base recipe. That's a crucial thing about this. Those machines completely converge. They go all the way to the end of the base recipe. They upload all their OHI data to the server. Their IP is up there. Their client key is all ready and everything. So at this point, they're all ready. You can actually encrypt the keys for Chef Vault. Searches are going to work, and that's an interesting thing. Sometimes the only thing that really was the blocker for the ordering of setting things up is they need to be able to find each other's IPs. And so if you can set up everybody on their base role, you can actually then do everybody else in parallel because they can find each other's IPs. They may not be up yet, but they don't care about that. They just need to be configured to find each other. So that way you can actually get rid of all of the serial time. So yeah, what you can do for your specific thing is there are Chef Vault APIs, and I don't know them well enough to do it right here, but you could do like a search for these guys. You can go and grab the client keys for them. You can do the Chef Vault stuff after the base role. And there is another thing in Chef Metal that'll probably help you, which is you can do a file upload. So if there is something like for encrypted data bags was the reason for this.
I'm doing exactly that for encrypted database now in the Chef Vault. That does work.
Cool. So yeah, you specify a local and a remote path, and it'll upload before it does the check. That is how the parallelism works. See if we're anywhere else. And feel free to interrupt with any other questions. You already have it, and that's cool. So there's a bunch of drivers already, and there's a lot of support for drivers. We need and want more, but it's pretty easy to do to make one, and I think I have a slide for doing that. Basically, you just extend the driver interface and you implement form methods. It's designed like there's a lot of work that Metal does, but it turns out a lot of it can be abstracted away from that interface that's talking to AWS or Vagrant. A lot of the work is SSH or knowing the Unix commands that you need to do to set up, or knowing how to set up Chef. So those things have been abstracted away into other utility classes that you can just new up one of those classes and return it in here. And the driver can then concentrate entirely on like implement allocate machine, which is make the AWS request and say, please give me 100 machines. Down button is pretty easy to touch. So allocate machine's job is to just go ping AWS quickly and set it up. And ready machine's job is to sit there, wait for it to start up, and then get it. Actually, that doesn't even get it set up. It just sit there, wait for it to get it set up, kick it if it needs to be, things like that. And part of the reason that's actually done separately is you can actually do a machine batch that does all your allocates. So like it's for even more speed. If you have a bunch of other stuff that you want to do in your recipe besides set up machines, you can set up a machine batch at the beginning. It just says, hey, go tell AWS to start provisioning me 100 machines. And so you say like machine batch action allocate. Then you go set up all your other stuff locally, do a bunch of work, and then come back and say, now I want you to actually converge the machines. They're probably warm by now, depends on how much work you did. But it lets you use the chef lines time efficiently. And that's the main thing. The driver's job is to return a machine object. It's the thing that lets, once it's actually got the machines up and ready, it returns the information you need to connect to it with SSH, and things like how you should converge the machine, stuff like that. So you just new up one of those at the end of the driver, and you're good. New up one of those, and same kind of thing there. Convergence strategy is like, how do you set up and run Chef? So I'll skip through this a little bit. If you, I can go through more tomorrow if you want. The other methods are connect to machine. So like I wanted to be able to enable those commands. So what I wanted to write a command line that could go and grab the node and then connect to the machine. Woo! I'm gonna laser pointer.
Do that.
You mentioned that maybe it was with your setup that the SSH keys and stuff that allow you access to the actual machines out there in the field that are created wherever they're created out there in the cloud, they're stored.
Mm-hmm.
They're stored on your machine and you lost power and you can't get your machine out. Yep. Is there some form of database backend for this or backend?
So the
storage part of it, so it can be stored in some common area where other people get to it? Or is that stored?
Yes and no. You can store it wherever you want and use keys as input to Chef Metal. So like I think that's a really important thing in from scenario. The only reason it's creating a key on my machine is so I can quickly set up and make it go. But you can actually specify, where the heck is that? You can tell it I want to use this private key over here, right? And so what you can do is download it, or another thing you can do is to tell it I want you, sure, Chef Metal, go ahead and create the private key, but here's where I want you to dump it onto disk, and then you can actually upload it into whatever your system is for storing these. I think we're pretty close anyway. Machine options are worth talking about. So like this is the thing where when you're setting something up on Vagrant, setting something up on AWS, setting something up on Google Cloud, the options are entirely different. And Chef Metal's philosophy is to stay out of the driver's way and let you specify whatever options that cloud allows. So it doesn't try to create an abstraction that says, I want 8 gigs of RAM, go figure out how to do that on AWS or Google or Vagrant. Instead, it just says, it lets you specify exactly the things that the underlying cloud supports. So you specify the AMI, and that's how you do that. Or you specify the instance type, the X1 large. And that's how you decide how much memory you're going to have. The driver decides what goes into it. Metal just steps out of the way. You can see some Vagrant options and EC2 options. We've got image ID and flavor ID, and anything that you can put on an instance. Anything that Fog can put on an instance or Vagrant can put on a VM, you can specify.
So the keys are right from whatever the underlying.
Yes, those are actually the Fog keys, and those are actually the Vagrant options. It literally just steps out of the way. Any abstraction I put in the way is going to eventually crumble because they're going to change the underlying stuff, and it's going to be more awesome, and Metal's going to be less awesome if I did that. And this is the bit about you can put different machines in different places. 1.0 is soon. What's interesting is that this slide was created 2 months ago. But yes, time interview. It's about a month away, I think. What we have left to do in 1.0 is stabilization testing, which means running each of the drivers 150 times in a loop and getting green the whole way through. There's a few bugs that need to be fixed, but we're not. The interface is done. There's no new big features that need to be put in. Although I'm not really releasing it till I create a meta driver, till an action, or they're all going to laugh at me. Yep. Many ways to help. Please, tomorrow we're going to have a hack day, and I will help if anyone wants to play with it or play with anything in Chef. I've done lots of Chef things, so I'm happy to help with anything. So, any questions?
You mentioned, I guess, the Chef Metal, you try to stay out of the way of what the drivers might do. I don't know how involved you are with the fog driver, but I'm using that with AWS. And there are things outside of the machine, like security groups, IAM, instance profiles, and elastic IPs. So I'm working with some of these things, and there is an AWS cookbook, so I can use Chef Metal to bring up the machine, and then inside of that machine, when it converges, it can go out and create things that it needs, except for maybe security groups that have to be there ahead of time. But I'm wondering if those, do you feel that those belong as something that Chef Metal might invoke, or is that something that should happen from within the machine, or where do you see that going?
So the external resources besides instances, there's other stuff we want to configure, and that's all important stuff to do. I think that it actually does fall, the AWS resources are something that we want integrated with Chef Metal because a lot of what Chef Metal does is make it so that you specify how you get your configuration and your keys and how you decide which region you're going to connect to and all this stuff. And you do all that work to get it set up for your instances. You'd like all that work to still apply when you want to set up load balancers and things like that. So yes, they need to be separate resources. They're not going to be part of the machine resource because they're different things.
You could now today just put VirtualBox in the metal messages that would do things, and then I presume that the AWS cookbook you could run at provision time as well.
It absolutely can.
You could have the keys on your machine and go on that phone, same message. Yeah. Just wondering if that's something you think, is that not the job of Chef Metal? Is that something that I would do with a Ruby block probably long term, or is that something that you think belongs in Chef Metal?
I think it belongs. I think it fits in the circle of Chef Metal. I think, like, as people need external resources, we will collectively build them. And I think that they should be plugged into the driver framework so that we can all be using the same configuration. And when we take that cluster cookbook, it's got a load balancer and it's got machine definitions. When we apply it to the AWS East region, then it should put the load balancer there as well as that. As long as they have shared configuration, and I think that we could probably do that with existing resources. We can probably just get them so they can share configuration or have two different. They'll notice if metal configuration is set up.
When you use like containers, right? You spin out those containers on one instance, or you can actually split those containers in multiple, like for example.
Metal's fairly good at inception. So you're always, when you're creating containers, you're creating them on the local machine. Like you're creating a bunch of LXC containers. That's where you're putting them. There are some things now where you can actually say, I want a container over here. And we don't think we have a driver for that yet. But for LXC in particular, what you're doing is you're creating the LXC containers on the current machine. And what you would do is you set up a master provision recipe that says, I want 10